everyone, welcome back to my channel. In today's video, we will create a small to-do list app using clean architecture and room database. In the previous video, I have already explained clean architecture in detail, so I recommend that you first watch that video and then create this project. Now, the app is fairly simple. You can add a task, view the to-do list, edit a task, and delete a task. The task will be stored in the room database. Also, you will learn how to seamlessly use clean architecture in your project. So let's create it. Open Android Studio, create a new project. I will name the project Clean To Do App. Click on Finish. The first step is to add dependencies in Gradle. Hence, go to the app Gradle, add plugin and dependencies for the room database and coroutines. Click on Sync Now. Then, as we are creating the project using clean architecture, hence create its 3 layers as the 3 packages: data, domain, and presentation. Now, in the data package, we will include the 3 components of the room database, that is, entity, DAO, and database. If you want a detailed explanation of the room database, you can click on the I button to watch. So first, create a data class, TodoEntity. We call the entity annotation that represents a table named My To-Dos in a room database. The entity annotation tells room to treat this class as a database table. Each object of this class represents one row in that table. First is the ID property, initialized with 0. Then it is marked with primary key, auto-generate is equal to true, meaning it acts as the unique identifier for each to-do item, and its value will be automatically generated by the room database. Second is the title property, which stores the task name, while each turn is a Boolean flag defaulting to false that indicates whether a task is completed or not. Next, create an interface, TodoDao. TodoDao interface is the bridge between our app and the room database. It's where all the data magic happens. The DAO annotation tells room that this interface contains methods to access the database. The first function, getAllTodos, runs a SQL query, hence give a query annotation. The query says select star from the table name, that is My To-Dos, and returns a flow of list of to-dos, that is TodoEntity, meaning the app can automatically react to any changes in real time. Then create a suspend function, insert, which adds a new to-do item, that is TodoEntity, to the database. Then give it an insert annotation, and if an item with the same ID already exists, it replaces it using onConflict. Then update function modifies an existing to-do. Here, use the update annotation, while the delete function removes the to-do. Together, these methods perform CRUD operations using the room database. Next, create a class TodoDatabase. This is the main gateway to your app's entire room database. The database annotation tells room that this class defines a database, and it lists all the entities, in this case just TodoEntity, that represents its tables. The version is equal to 1 indicates the database version number, and export schema is equal to false, which simply means room won't save the database schema in a folder. The abstract class extends room database, making it the central access point for all your app's stored data. This is an abstract class, meaning an abstract class is a class that can't be directly instantiated. You can't create objects from it. Instead, it serves as a blueprint for other classes to inherit from. It contains both abstract methods without a body and a regular methods with a body. Inside, there's an abstract function, TodoDao. This connects the database to the TodoDao interface, allowing the app to run all those CRUD operations. Now next, moving on to our domain layer. Here, first create a data class, Todo. This Todo data class lives in the domain layer, which means it represents the core business model of your app. Clean, simple, and independent of any database. It defines what a to-do item is in your app's logic. Each to-do as an ID, default 0, a title describing the task, and is done flag defaulting to false, showing whether it's completed. Unlike the to-do entity in the data layer, which is tied to the room and database operations, this class focuses purely on business logic. Then next, create an interface, TodoRepository. This is the TodoRepository interface sitting in the domain layer. We do have one more repository in the data layer which will connect the layers with each other. We will also create that later. Now, here it defines the main actions your app can perform with to-dos, but without worrying about how they are done. Think of it as a contract that says any class implementing main must handle these operations. It includes 4 functions. GetToDos, which returns a flow of to-do list that updates in real time. Then AddTodo, UpdateTodo, and DeleteTodo are suspend function used to add, modify, or remove a to-do asynchronously. The real implementation of these functions happens in the data layer, keeping your business logic clean and independent from the database. Next, create a class AddTodoUseCase. The AddTodoUseCase class is a part of the domain layer. It focuses on a single specific piece of business logic, that is adding a new to-do item. The class takes a to-do repository as a dependency, meaning it doesn't care how data is saved, just that it can be. Then create a suspend function, execute, which takes the title as the parameter. Inside the execute function, it creates a new to-do object using the given title and sets is done to false. Then ask the repository to add it. In short, this use case represents one clear action the user can perform, that is adding a new to-do, and keeps that logic neatly separated from the UI. Next, remember I said there will be 2 repositories, one in the domain and another one in the data. So create a class in data layer, that is TodoDataRepository. Why do we have 2 repositories? Because the TodoRepository interface in the domain layer defines what operations can be done. It's just a contract. And the TodoDataRepository in the data layer provides the actual implementation of those operations, handling database work through the DAO. This separation makes the code clean, testable, and flexible, so you can easily switch to any other data sources without changing your app's core logic. Now let's write the code for TodoDataRepository. This TodoDataRepository class lives in the data layer and acts as a real-world implementation of the TodoRepository interface. Its job is to handle how data actually moves between the database, room, and the domain layer. It takes a TodoDao as a dependency, which gives it a direct access to the database. It also extends the to-do repository present in the domain layer for communication. The to-do repository has 4 members, so implement all of them. The first is getToDos, function that listens to all the to-dos from the database using a flow list of to-dos. Then returns all the to-dos using map. It creates a list by mapping each to-do entity data model into a to-do, which is a domain model. Like ID is mapped to entity ID, and likewise title and is done. So the domain layer never has to deal with database details. The other three functions, add to do, update to do, and delete to do the reverse. They convert the domain model back into the database entity. See, DAO insert to do entity, which takes the title, is equal to do title, and is done is equal to do is done. Likewise, we will do for the update to do and delete to do as well. Basically, when adding, updating, or deleting, you converted a to-do into to-do entity to save to the database. While reading or displaying a list of to-dos, you convert to-do entity to to-do. So the domain layer works with a clean and independent database. Look, our app's domain layer should not depend on the database or UI. The database and UI can depend on the domain. In short, we are doing all of this so that our classes follow the clean architecture principles, which is that every layer should be separated from each other. So even if you change the database or UI, it won't break the logic. That's how separation is achieved. The simplest way to explain this dependency is to go to any of these three classes in the domain layer. None of them is dependent on any other layers. But when you go to the class TodoDataRepository, which is the part of the data layer, you see it extends TodoRepository, which is the part of the domain layer, which ultimately proves that the data layer is dependent on the domain, and domain is fully independent. Hence, in future, if I replace the room database with Firebase, my domain layer, which is my core logic, will remain the same. Only the data layer classes will change. That's the beauty of clean architecture. Now let's move on to the third layer, that is the presentation layer. Here, create a class TodoViewModel. This TodoViewModel is the bridge between your app's UI and the clean architecture layers underneath. This ViewModel class starts with open class TodoViewModel application Android ViewModel application, which means it inherits from Android ViewModel, so it has access to the application context, useful for creating a database. Also, it's an open class, which means it can be inherited by other classes. Next, private DB is equal to room.databaseBuilder application TodoDatabase class my underscore todo underscore db. This is the database name dot build. It builds a room database instance name my underscore todo underscore db using the TodoDatabase class. Then private TodoRepository is equal to TodoDataRepository db.TodoDao. It creates a repository by passing the DAO from the database. This repository knows how to interact with stored data. Then private AddTodoUseCase is equal to AddTodoUseCase TodoRepository. It setups the use case for adding to-dos, encapsulating the business logic for that action. The line open to-dos is equal to TodoRepository.getTodos.stateIn ViewModel scope sharing started lazily empty list. It listens to all the to-dos as a state flow, so the UI can observe changes reactively. It starts lazily in the ViewModel scope and defaults to an empty list. Here, the lazily means that the flow doesn't start emitting data immediately. It will start only when it's first observed. Then come the user actions. Function AddTodo title string. It launches a coroutine in ViewModel scope and calls AddUseCase.execute title to add a new to-do asynchronously. Then function toggle to do done Todo also launches a coroutine and calls TodoRepository.updateTodo. Todo.copy is done is equal to if not Todo is not done to flip the completion status of a Todo. Next, function edit Todo new title. It also launches a coroutine, and if new title is not blank, then it updates a Todo's title by using the copy method. Finally, function delete Todo calls a repository delete Todo in a coroutine to remove a Todo from the database. In short, every line carefully connects the UI to the domain and data layers, handling the data asynchronously, keeping the app reactive, and maintaining clean architecture principles. Now finally, let's design the UI using Jetpack Compose. You can add the UI class directly here in the presentation package also because it's a part of it. But I personally like to keep it separate in a different package for clarity. Hence, create a package UI screens. Inside it, create a class TodoScreen. This is a composable function. There's a lot of code to write in here. Hence, we will speed up because there's nothing much to explain here, it's just UI only. But wherever required, of course, I will explain. So first, it calls TodoViewModel. The screen starts with where task by remember mutable state of to hold the current input text. And well to-do list by TodoViewModel .todos collect as state with lifecycle to observe the list of to-dos reactively from the view model. Add imports. Next comes the scaffold, which provides a basic layout structure. The first component of the scaffold is top bar, which displays the title of the screen, which is to-do list. The container color is red and the title content color is white. Add experimental API. Inside the scaffold inner padding, then a column arranges the content vertically with padding to avoid touching the edges, so fill max size and 16 dp padding. At the top of the screen, there's a row for adding a new task. The row is fill max width with 8 dp horizontally spaced by, then an outline text field for typing the task. Add all the parameters in it as shown, including value, placeholder, shape, and colors. Then below it, create an add button. When the button is clicked, if the input is not blank, it calls TodoViewModel .addTodo the task and then clears the input. The button color is red and the button text is add. A spacer and a red horizontal divider visually separates the input from the list. Again, a spacer of 12 dp height. Then comes the to-do list using lazy column. The lazy column is fill max width and vertical arrangement spaced by 4 dp. Then we have items. Please use the correct list imports, otherwise it will throw an error. The items consist of a to-do list and a key, which is our ID. This block iterates over each to-do in the list, using ID as a stable key to help Compose efficiently track item changes. For each to-do, two state variables are declared with remember todo.id. Is editing tracks whether the current to-do is in edit mode. A new title holds a temporary text when the user edits the task title. By tying the states to todo.id, each row keeps its own independent state, ensuring that editing one to-do doesn't affect the others. This setup allows each list item to reactively toggle between display and edit mode, while preserving its individual content. Next, it displays each to-do as a row. The row is centered vertically, fill max width and 4dp vertical padding with space between horizontal arrangement. Inside the row, we have another row which is centered vertically. Then inside that row, create a checkbox to toggle its completion state using isDone and ViewModel. And keep the checkbox color as red. Then each row also supports editing. So if is editing means if the user has clicked the edit icon, toggles an editable outline text field with its parameters. Then next to it, a save button, allowing the user to store the new task title into the database using the view model. The button has 4dp start padding, red color, and a button text that says save. Else, if it is not in editing mode, then just simply display the task title next to it. If the to-do is marked done, the title shows a line through like a strike through, else keep it as it is. Next, again, create a row that consists of two icon buttons for edit and delete. The first icon button is edit, which shows a red edit icon when clicked. It toggles is editing to enter or exit edit mode. And if editing is just starting, it resets new title to the current to-do title. So the user starts with the existing text. The second icon button shows a red delete icon. When clicked, it immediately calls TodoViewModel.delete to remove the to-do from the list and the database. Together, this button lets each to-do row be edited or deleted individually, with all actions linked reactively to the view model so the UI updates automatically. Lastly, go to the main activity, remove the default code. The main activity, the entry point of the app. It starts by creating a TodoViewModel instance using by ViewModels, which ensures the ViewModel survives configuration changes like screen rotation. In the onCreate method, it calls setContent to define the compose UI. Inside it, it wraps the content in a material theme for consistent styling and a surface as the background container. Finally, it calls TodoScreen. TodoViewModel is equal to TodoViewModel, passing the view model to the screen so the UI can observe and interact with to-dos in real time. And that's it. Our to-do list app is ready using clean architecture and room database. Now let's run the app. This is what the app looks like. Write a task, add it, and see, it immediately displayed here. You can edit it, save. You can also delete it. I will quickly add more tasks. The app is pretty simple, but more importantly, it is how we have used clean architecture and the room database in it. Further, we will create more complex projects using these concepts. Okay? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel and I'll see you in the next video.